Which graph best represents the solution to this system of inequalities? So each of these inequalities is going to look like a line with some shading above or below, and where the shading overlaps is going to be the solution. That'll be one of these gray regions in the options. So we're going to start by writing each of these in the form y equals mx plus b. Then it'll be easy to draw the line and then see where we need to shade each of them. So starting with the first one, we have 2x is greater than or equal to y minus 1. We'll start by adding 1 to both sides. That gives us 2x plus 1 is greater than or equal to y. Now let's recall that our inequality sign is comparing the sizes of two different things. And we talked about Pac-Man and how he's always facing the bigger thing. So 2x plus 1 is the big item here, and then y would be the small one. So if we want to write this inequality in the opposite order, with y on the left side and 2x plus 1 on the right side, we'll need to flip our inequality sign. So Pac-Man continues to face our bigger item. So now we have our small is less than or equal to our big. So this is saying the same thing as the line above. However, having the y on the left side lets us see that y equals mx plus b form. So this inequality is telling us two different things. It's saying that y is less than 2x plus 1, or y is equal to 2x plus 1. So y equals 2x plus 1, that's something we're familiar with. Looking at our graph, it's going to be this purple line over here. And y is less than 2x plus 1 is going to be the region below the line. So that purple region, including our line, is going to be the first inequality. And we have to go through the same process for the second one, and then see where those regions overlap. So our second inequality is 2x minus 5y is less than or equal to 10. Again, we're going to write this in y equals mx plus b. So we'll start by subtracting 2x from both sides. That gives us negative 5y is less than or equal to negative 2x plus 10. We'll divide both sides by negative 5. And since we divided by a negative, we need to flip the inequality sign. So we have y is greater than or equal to. And on the right side, we'll split this up into two fractions. We'll have negative 2x over negative 5 plus 10 over negative 5. Simplifying this, we have y is greater than or equal to 2/5 x minus 2. Again, this inequality is going to be two different statements. It says y is greater than 2/5 x minus 2, and y is equal to 2/5 x minus 2. And that second statement is going to be this pink line. That is y is equal to 2/5 x minus 2, and y is greater than 2/5 x minus 2 is going to be the region above the line. So any point that you pick in the pink region is going to make this inequality true. You just plug in those values for x and y, and this will be a true statement. So the pink region is all the x and y values that make this inequality true. Similarly, the purple region is all the x and y values that make this inequality true. And the region where the pink and purple overlap, that is where both of those inequalities are true. So that's going to be this region that's right here. That is where the pink and the purple overlap. You can pick any point in that region and it will make both of our inequalities true. So we say that region is the solution to this system of inequalities. So each of our options is shading a different area and claiming that that's the solution. However, option C is the only one that marks that green region, so that's the answer. What is the solution to this system of equations? We have y equals negative 3x minus 2, and 6x plus 2y equals negative 4. So we've learned two ways to solve a system of equations. We have substitution and combining. Since our first equation solves for y, this is perfectly set up for substitution. We can just take this piece right here, negative 3x minus 2, and substitute it for y in the second equation. So let's go ahead and do that. Our second equation would look like 6x plus 2 times, and then we'll substitute in for y, negative 3x minus 2, and then we have equals negative 4. And now we can solve for x. We have 6x plus, and then using the distributive property, 2 times negative 3x minus 2 times 2. So we'll have 6x, and then 2 times negative 3x gives us a minus 6x, and 2 times 2 gives us 4. 6x minus 6x is just going to cancel, and then we're left with negative 4 equals negative 4. So what does this mean? If you notice, since we canceled out our x's, we could put in any value for x, and it would still make this equation true, because our x's just cancel. So x could be any number. So let's make a note of that. Any value of x makes the equation true. Okay, let's take a look at this second equation and see if it can help us understand this. So let's write it as y equals mx plus b. So we'll start off by subtracting 6x from both sides. That'll give us 2y is equal to negative 6x minus 4. Dividing both sides by 2 gives us y equals, and splitting this into two fractions, we have negative 6x divided by 2 minus 4 divided by 2. Simplifying, we have y equals negative 6 divided by 2 gives us negative 3 minus 4 divided by 2 gives us 2. So our second equation here is the same as the first one. So we have two lines here that are exactly the same. And if you have two lines that are exactly the same, where do they cross? They cross everywhere. Let's think about this on a graph. Our equation has a y-intercept at negative 2 and a negative slope. So it's going to look something like this. Let's say that's our first equation. That's going to be our first line. And we can mark our second line in pink. You can think of our pink line as being right on top of the green line. So these two lines end up intersecting everywhere. Every point on this line is a solution to this system of equations. And that's what we learned over here. We saw that any value of x made the equation true, so we can pick any value of x and find the y value, and that would give us one of these purple points. So when you get a true statement like this, where the x value drops out, that means that there is no one x value where these two lines cross. In fact, every x value is going to be somewhere where the two lines cross, because they are the same line. And since you can always pick a new x value and get a new y value, we would say that there are infinitely many solutions. So that would match option D. Which ordered pair is the solution to the system of equations below? We have x plus 3y equals 7 and x plus 2y equals 10. Again, we can use substitution or combining. And since we have the x and y values on the left side, they're lined up and we can use combining. So let's practice with that method. We'll start by rewriting our equations. Now when we combine, we're trying to get rid of one variable, and we can pick whichever variable we want. And x would be the easiest one to get rid of, since we just need to multiply both sides by negative 1. So keeping our first line the same, our second line becomes negative x minus 2y equals negative 10. So now we can add up the pieces on the left side and the pieces on the right side. On the left side, x minus x makes our x's go away. 3y minus 2y gives us 1y. And on the right side, 7 minus 10 gives us negative 3. So we're looking for the point where these two lines cross, and we just found the y coordinate. And if you look at the answers, you might notice that there's only one choice, option D, where y equals -3. So if you notice this when you're taking the test, you could just circle D and move on. But for this video, let's make sure we understand how to get that x value. We would take our y equals -3 and then substitute it back into one of our equations. So let's take the first equation. We would have x plus 3 times, and then for y, we'll put in -3 equals 7. That gives us x, and then 3 times -3 gives us -9. Adding 9 to both sides would give us x equals 16. So that confirms that our point where the two lines cross is 16, -3. And again, looking at our answer choices, that's option D,